All right, you guys, let's go ahead and get started on section 3. Section 3 starts talking about experimental studies. It says scientists at a local research facility wanted to see how lack of sleep affected student achievement. They split a class of students into two groups. One group was able to sleep as they normally would, but the other group were woken up every hour and forced to stay awake for at least 5 minutes. The scientists continued this process for 2 weeks and calculated the differences of their grades. So the first question says, is it observational or is it experimental? Well, it is experimental. The reason why it's experimental is because a couple things we could look at really, but number one, has a treatment. Not only does it have a treatment, but it talks about the exposure of two different groups. One group got something, one group didn't. Your variable of interest is effect on grades or sleeps. Effect on grades, right? Does the amount of sleep affect the grades that you have? That's what the scientists are interested in. Remember, a control group does not get treatment. So in this case, they'd be the one that got the same old thing. So same sleep as normal would be the control group. And why? No treatment. The next one, one's the considered the experimental group? That's the one stay awake group. Why? They got a treatment. Remember, your experimental group is the group that gets a treatment. So no change for the control group. Experimental group gets the change, and the test is to see if the change works. So what was the treatment? A lack of sleep. They woke them up every 5 minutes, right? And I'm not going to write that, but that's what it is. They woke them up for at least 5 minutes every hour. What's considered the population? The whole classroom, or all students in the classroom. All right, the next one. Mr. Branson was curious as to how often a student's cussed in his classroom. He placed audio recorders in the classroom and then tallied how many cuss words he heard each day. No cuss words, obviously, in 208. But in this situation, what makes the study observational? No experiment. No treatment. Right? There's no control group. There's no experimental group. There's no treatment. There still is a variable of interest. Number of cuss words. He's interested to see how much his class cusses, so that's what he's interested in. All right, biased data says Dr. Holland asked all the parents of his basketball players what their favorite school sport was. Remember, biased data is just when the data that you receive is not representative of the entire population. So in this case, it's biased because he's asking parents of basketball players what their favorite sport was. They're probably going to say basketball. So in this case, that's what makes it biased, that he's asking parents of basketball players. Number 4, identify if the following studies involve collections of primary data or secondary data. Remember, primary data, collect it yourself. Secondary data, somebody else collected it. So it says Mr. Branson wanted to discover the components of a perfect golf swing. He found magazine articles and online journals that describe the perfect golf swing, compiled his results. He didn't do the research, somebody else did. Just because you're reading somebody's work does not mean you're actually doing the research, so that's secondary data. Letter B, Mr. Branson wanted to discover the components of a perfect golf swing. He went and interviewed all of the students and coaches that were associated with the TCHS golf team. He's doing the interview. Primary. He's doing the data collection. So don't get that mistaken with this up here. Somebody else did the data collection. He's just reading about it. Number 5, what does it mean to be unethical? I think there's a lot of definitions that you can use in this situation. I think unethical just means morally wrong. I think that's kind of what we talked about. Quick 2-word definition. Remember, situations could be unethical if you're not informing somebody. Remember, we talked about not giving informed consent. So I'm going to write that down. But other things could make something unethical. If you're giving somebody a disease, if you're doing something that's morally wrong to a group of people, that's unethical. Number 6, sampling methods. We had 6 sampling methods. The first 4 sampling methods were all random samples. You had systematic, simple random, which both of those did not have groups, in which case systematic had a system that went with it, and simple random did not. You also had cluster and stratified. Remember, cluster and stratified were both random, but they both involved groups. Cluster, the entire group was part of the sample if it got selected. Stratified, a sample of the group was selected. And then the last 2 were convenience and voluntary. Those are not random. Voluntary, the participants had to volunteer their information or volunteer their time to participate. Convenience was something that was not random. It was just convenient. They got information that was right there, not representative of the entire population, not random. Excuse me. So if we look at these, letter A says, in order to check the quality of coffee, Starbucks samples every 100th bag of coffee they produce. That right there is a system. So therefore, this is a systematic random sample. Letter B, the mayor of Tifton wanted to know how Tiftonites felt about the new stores coming to Tifton. He split up Tifton into 8 regions and held town hall meetings and locations inside each of the 8 regions. He randomly chose 3 responses from each. This is a big key word. He picked from each town hall meeting to put in the Tifton website. So it is random. There is randomness to it. There is groups. He's selecting from each group. Since it's from each group, this is stratified. Letter C, it says a local news broadcasting station wanted to know how their viewers felt about Donald Trump. They allowed their viewers to tweet in their opinions. There's no randomness about it. You're only going to be able to be part of this if you watch that local news. So there's no randomness about it. And you have to tweet, so therefore it is voluntary. It's a voluntary, non-random sample. Letter D, in order to pick who was going to present problems during a closing, Mr. Branson's told all of his students to put their name into a cup. He drew names out, and those people had to present. Everybody had an equal chance, so therefore it is random. There was no system to it, and there was no groups. So in this case, that's simple random. Now, what I don't want you to get confused about is the fact that it's Mr. Branson's class. That's the entire population. That's not split up into groups just because it's only my class. Letter E, the commissioner of Major League Baseball wanted to know how many baseball players were on steroids. He randomly chose 3 teams to participate in drug testing. If your team got chosen, you had to participate. So it was random. There was groups based off of that. They're split into teams. And if the team got chosen, everybody had to be there. So the whole group, it's a cluster random sample. And the last one, Mr. Winger, a math teacher, wanted to know how many teachers properly knew the safety procedures at TCHS. During the next department meeting, he made the math department take a survey pertaining to school safety procedures. There is no randomness to it. It's not representative of the entire Tift County High School. Instead, it's only the math department. He's a math teacher, so it was convenience. So convenient sample. Hopefully I spelled that right. Not really sure. All right, the next one, frequency tables, stem and leaf plots. Remember frequency tables? We had a value and a frequency, or how often something happened. Stem and leaf, remember we had a stem and leaves. So we'll do the frequency table first. The smallest number I see is a 2, so a 2 happens, and it happens 1, 2 times. The next number I see is a 4, happens 1 time. A 6 happens 1 time. An 8 happens 1 time. A 12 happens 1 time. 16 happens twice. 18 happens once. 22 happens once. 25 happens once. 26 once. 32 happens 1, 2, 3 times. 33 one time. And 37 one time. So as you can see, frequency tables, not really a good idea if you don't have things that happen often. If you have a lot of stuff that only happens once, this is not a good organizational tool. So you need to recognize that. You could do it, but it doesn't really help you out with much. Versus a stem and leaf plot is very helpful when you're trying to organize things into groups. So in this case, I'm going to go ahead and erase these dashes that we just had. And we'll go back through them. Remember with stems, we talk about your tens digit or everything besides your unit digit. And so in this case, our stem would start with a 0, and that would be to represent all of your digits 0 through 9. So we have 2 happens, another 2, a 4, a 6, and an 8. So all of those had a stem of 0. Your next stem would be your 10 through 19. So that's 12. 16 happens twice. And then 18. Your next stem would be a 2. That's your 20 through 29. So 22 happened once. 25 and 26. And then 30 through 39. You had 32 happen 3 times, so I'm going to write that as 2, 2, 2. 33, 1 time. 37, 1 time. So notice this is very nice because it shows you groups. This would be really good if you were trying to figure out, test averages, things like that. It just shows that there are 5 numbers that fall in this range, 4 numbers in that range, 3 numbers in that range, and 5 numbers in that range. A little more useful. Okay. 5-number summary. We could find out the 5-number summary by going ahead and taking all these numbers, and we can list them out in order. We can find our minimum, we can find our maximum, we can find our median, we can find the median of the first part, we can find the median of the second part, which is our Q1 and Q3. Or what I'm going to do is I'm going to remember, hey, guess what? Our calculator does some of this statistic stuff for us. So I'm going to go to Stat, I'm going to edit, and I'm going to type in my list. So all of those I'm going to type in as a list. 5, 7, 2, 5, 12, 15, 19, 25, 32, 12, 15, 3, 16, 2, 7, 23, 15, 8, 2, 14. Is that all of them? Yeah. All right, the reason why this is nice, I don't have to worry about putting them in order. My calculator is going to do the move for me. So after I have them already listed, we go back to Stat. We're going to calculate. We're doing one variable statistics. And then we have to tell our calculator, hey, where did I put that stuff in? We put it in list 1. So we tell the calculator we want this list 1 right here. We tell it by the yellow second button. And then 1, and list 1 pops up. Remember, whenever we did this for a frequency table, we had to use a comma. The comma button was right there, and we told it where our frequencies were first, whether it was in list 1, 2, 3, 4, 5, or 6. We pressed the comma, and then we put our data was first, and then our frequencies came second. After I have this, since I only have one list, I press enter. It's going to give me all these things. Remember, we had the mean. If you wanted to use that, there was standard deviation right there. There was how many terms that you had, 20 right there. But then if you scroll down, there's your 5-number summary. Minimum, 2, Q1, 5, median, which is also Q2, 12, Q3, 15.5, and our maximum of 30. So 2, 5, 12, 15, or maximum of 32, excuse me. 2, 5, 12, 15.5, and 32. 2, 5, 12, 15.5, and max of 32. There's my 5-number summary. Well, now I have this picture and I have to draw this out. Remember how we did it? As we said, well, our minimum's 2. I'm going to go about halfway up. We put a dot that represents the minimum. Maximum's 32. Dot to represent the maximum. Our Q1 was 5, so Q1 gets represented with a line. Q2 is 12. Q2 gets represented with a line. Q3 is 15.5, so 15.5 we're going to have to estimate a little bit, is represented with a line. We're going to create our box and our whiskers. Now, even though this space is smaller than that one and that one, obviously, all of them represent 25% of the data. So it just shows this idea of spread out of the data by splitting it into quartiles. But that's how it would look if you had to create one. So now what if one's already created and you have to answer questions? So the first question, you have these two box and whisker plots. You could get the 5-number summary if you wanted to. You look at the first one, it says, what's the percentage of students in class number 2 that passed the test? Something that I'm going to do just to remind myself, I'm going to put each of these sections, even though they look different, are 25%. You could do that to the top as well. I'm going to leave it alone right there. So class 2, percentage of students that pass the test, well, passing is a 70. So 70 and above, there's 25, there's 50, there's 75% of the kids. What percent of class 1 that scored 80 or above? So you got your 80. Well, that looks like it might have been my median. So there's 25, there's 50, so 50%. Percentage of students in the class that scored below 75. So class 2, below a 75. That looks like it probably is a 75, so I'm going to estimate that. 25 and 50% scored below. How do the grades of the highest quartile of the two classes compare? There's a bunch of stuff you could put, right? Class 2 had higher grades, or class 2 max is higher. You could also say class 1 minimum is lower. And you could also say that class 2 is more spread out. So a bunch of stuff that you can say by looking at this highest quartile. It says in class 2, did more students score between a 50 and a 70 or between a 90 and 100? So in class 2, 50 and a 70, well, guess what? That's 25%. 90 and 100, that's 25%. It's the same amount, y'all. Couple things that you guys screwed up on with this. When you were dealing with this, you screwed up on the percentages, kind of thinking that that was something different. You screwed up on the word at least. Right? If we talk about at least a 70, at least a 70 means starting at 70 and going up further. So make sure that you're not making those mistakes. Keep in mind the difference between above and below, things of that nature. All right, that's the last part of section 3.